Hey folks, Quill18 here, and welcome to another video in our Unity base building game series. I want to take a look at potentially two things today, but it's mostly going to depend on how quickly the first thing gets wrapped up. So the first thing is this. Our little mining drone building over here has got that sort of weird job behavior where, actually a better example I think would be if I restarted from a fresh world, open up the pathfinding test, set up some wall building jobs. Obviously, we don't have any materials for this. And then we're going to go and put down the mining drone, which gets worked by our character, and then drops metal. And then once the job completes, so every time the job completes, 5 units or 1 unit of steel plates, I suppose, gets spawned over here. And then the job gets recreated instantly on the next update, but then it's at the bottom of the queue, and then we end up with this sort of back and forth shuffling. It would be a lot better if our character, well, either waited until there was a full 5 units of steel here rather than doing one at a time. That might be a job priority system, but the other thing might be if rather than the job sort of ending when it completes, right? I'm going to try to differentiate between the idea of a job cycle completes, which produces 1 steel plate, versus the job being ended or stopped, I suppose, which would happen when this tile, for example, is full of steel plates. We clearly cannot work on the job anymore when this fills up. And actually, that's one of the things that right now, this would eventually fill up and have 50 units of steel here, and the job would still be on the queue. We may have put in a check for that, actually. I think we did. But the result remains that maybe it's better if the job wasn't actually stopped when a cycle of the job completes. And so what I want to introduce is the idea of a job that sort of self-repeats. It's a repeating job. It's not a one-shot job, for example. It's a cycle that stays there. And the idea being that when you complete a cycle, what it does is it resets the time to do the next work unit, and otherwise doesn't end. We could do it where when the job completes the cycle, it puts itself at the top of the job queue. But even that's not necessarily going to do the behavior that we want, because it's still possible for the job to complete 1 cycle. And once we have a second character, the second character is looking for a job and ends up grabbing that first. So you still end up with a little bit of awkward shuffling. So I think what we want to do is we want to go ahead and introduce in our jobs class over here, we want to make a couple of changes. So first of all, we're going to want some sort of Boolean that you can set that, and actually probably be protected. Bool job repeats. I mean, yeah, I mean, it repeats. It just keeps going when it ends a cycle. And it'll default to false. And most likely, do we want to set it as part of the constructor? I'm not sure. We'll take a look at that in a second. But the other thing we have to do is keep track protected float job job like required time. I'm going to differentiate between job time left and job time for an entire cycle. Job time requirement is probably okay, or required, I think, is going to be fine. So we'll set it there. And where do we set the job time? Well, it's protected on the set. So the only place we can set it externally, and in fact, the only time we do set it from the external, is in the constructor. So right over here, we're also going to put in this dot job time required is equal to this. So that way, when the job ends, we can reset job time to job time required and get another repeated cycle, which is good. Maybe I'll go ahead and just change the constructor up over here, and we'll put in a Boolean job repeats, and we'll have it default to false. And that way we don't always have to supply it. And then this job repeats is equal to job repeats, like that. Okay, so that's one thing. The other thing I want to do is I want to distinguish these callbacks over here. So job complete. This is when we finish a work cycle. But the big difference is going to be that we have to remember now when job complete callback gets called, that doesn't mean the job has stopped. And what I'm actually going to do is I'm going to rename job cancel. Instead of being job cancel, it's going to be the callback when the job stopped. Actually, this callback should really be job completed, I think. There we go. So we've got callbacks now for when a job gets completed. we have finished the work cycle, and so things should probably get built or whatever. This one here is the job has been stopped either because it's non-repeating or was canceled. And then gets called each time some work is performed. Maybe update the UI, something like that, right? So that's what the role of these things are. I'm also going to go and just rename these callbacks. So it's going to be job completed callback. And I use F2 to rename this, by the way. Very, very easy. And so this is not just job canceled, it's job stopped. Just a subtle little difference in naming, which is going to add some extra clarity. And for unregistering and for unregistering the stopped job. So right now we haven't done anything that changes anything up. We'll make sure that everything compiles okay. Let me just clear this. Did it not update? Save. Oh, I see. It made the change, but because I had it open, it didn't actually save it. There we go. So save that. So now everything is working out fine. Everything is working the same way as before. But what I'm going to do is change the registrations here. So we've got to make a couple of changes here and there. When our character gets a job, our character doesn't actually care when a job cycle is complete. Now, because if he's working a repeating job, it's fine. He'll just keep working the same cycle over and over. What he cares about is when the job gets stopped. And actually, I'm going to replace the name of onJobEnded to onJobStopped to make that clear. Job completed if non-repeating or was canceled. And we don't have to unregister this callback because we don't actually have this. So we'll unregister the job stopped callback. And we'll still give a little throw a little error if something happens, and there we go. So that's good. Now, our job, when does it fire this off? Well, over here in do work, when some amount of work on the job is performed, we make sure we've got all the materials and everything is valid. We reduce the job time. We call the job worked callback if we need to. Then if the job time is less than or equal to 0, then we call the job completed callbacks. What we have to add at this point is we also have to potentially stop the job. Oh, this function over here, cancel job, I'm going to call this... No, I think cancel job still makes sense here. Because this is the version where it is actually canceled, which means we stop the job, but we also remove it from the queue. This is very different from a job that has been paused, which we don't really have that. It can happen. I can't remember where. I'm actually not sure if we have anything like that. Because if you are canceling the job, or sorry, if you are stopping or pausing the job, what you are doing is you'll probably call, will you call job stopped? Maybe not, but you re-enqueue it. Yeah, we'll worry about that after. But anyway, in this piece of code right over here, right? So job time has completed. Or, yeah, so we call job complete because whatever is supposed to happen, do whatever is supposed to happen when a job cycle completes. And then we do another check of if job repeats is equal to false. Then we also say, we call if CB job, if CB job stopped not equals null, then we call that CB job stopped with this. Let everyone know that the job is officially concluded. And that's all we need to do there. But else, this is a repeating job and must be reset. So what we do is we set job time plus equals job time required. And we're doing that instead of setting it because it's possible that we've overkilled the job construction here, right? Imagine we were sitting at, 0.000001 seconds left of work time left, and our character has just put in 0.1 seconds worth of work. Well, it would be nice if the overflow was applied to the following tick or the following cycle of the job, which is what this is going to do. So that's really nice. And I don't think we have to do anything else. Our character should continue to work this. So first of all, let's make sure, well, I guess I'll go ahead and change the, let's make a test to make sure we haven't broken anything as is. Because nothing has job repeating equals true right now, everything should work the same as before, but it's calling callbacks in a slightly different fashion. So we're going to have to make sure that we're okay. So I'm going to load this version of it, which automatically gives us some plates here. And I'm going to build a wall over there. You're going to grab stuff. You're going to go there. You complete the job after a second. And if we put down some more work, everything seems to be fine. We're not getting any weird errors. That's great to see. Let's go and put down a mining drone over here after that. This is not set to repeating. Actually, let me start a new world. Load just a pathfinding test. Queue up a list of walls to be worked here, which isn't going to work because we don't have any materials, so we're going to get some errors. We'll put down the mining drone. And we should be back at the thing where it builds 1 unit of steel, dumps it off, and over here. All right, as far as I know, we are okay over here. Oh yeah, actually, the job being requeued. Ooh. Oh, this error I think is what happens when I just hit stop, which is probably okay. This job being requeued is actually a great example of the one place where a job sort of gets paused. It's because we started working it, and then we didn't have the materials, so we went back somewhere else. So where does this happen? So, I mean, this is an error thrown by the visual controller, which is fine, but I just want to verify things. So job queue, which I have open at line 31. Right, this is when we're re-queuing a job that had gotten paused. And then it says character 213. Character line 213. Oh, it's when we're abandoning a job. Yeah, which is fine. So we're not calling any job stopped callbacks or anything like that, but it's probably okay. The one thing we might want to do is move some of this logic to some other function. I guess we're okay for now. I suspect we'll probably need a little bit more logic around this at some point, but we seem to be just fine. Okay, so now what we're going to do is we're going to make a change to our furniture actions for our mining drill. That's where we create the job. So our mining drill creates the job, and what we're going to do is we're going to tell it that this job repeats until the destination tile is full. So we set that to true. So now when we you know what, this furniture, this put where we remove the job. So okay, so this is going to get called every time a job completes, but that is no longer the same as a job stopping. So we want to remove the job from the furniture only when we actually stop the job outright, and not before that. And I think it's probably a good idea if on this job we have a different callback. If I take this, if the job gets stopped for any reason, that's when we're going to want to remove the job from the furniture. In fact, we might want to have this be something that a job is automatically aware of. But right now, jobs aren't aware that they belong to furniture. It only goes the other way around. So on our job, we're going to register a job stopped callback, and we're just going to feed it in this function over here. So if ever the job stops, we'll do this, and we'll clean up some stuff about it. Okay, that's good. So now, if I don't do anything, we should get a really sort of funny behavior because this job will never end. It literally doesn't, even if it gets full. So I think what we can do here is we can make sure that this is working sort of inaccurately. We're not done yet. We'll set up this, we'll build the mining drone, And now our character should never stop mining. And indeed, that is true. Oh, I don't actually have a display to show me in the tooltip how much stuff is sitting here. But I did see the little number change just barely underneath our character here. There, and again. So, he is sitting here. The job is repeating because it's never stopping at this point. Which is good. Although, we do want some sort of break. Clearly, our character is going to have some sort of overriding logic where they might abandon the job if they get hungry or thirsty or tired or something like that. That's fine. They can just, call abandon job at that point, and that will be totally okay. The job will just get re-added to the queue. Someone else can take over. But here's more important. If we have a job, we can't just return instantly, because what we have to do is check to see if the metal plate destination tile is full. Okay? So that's what we're going to do. And if it is, then we have to actually kill the job at that point to let the character go. There's 50 metal plates already in the tile. Working this isn't going to help or do anything else. So just abandon ship and move on to some other task over here. So, how do we do that? It's an excellent question. If we take a look at our furniture class over here, take a look at our furniture class, we have a job spot, and that's also where we're spawning stuff right now. Actually, we can see that quite clearly if we take a look at our furniture actions, right? We are currently placing inventory at the job tile, right? So the job's got a tile where we're spawning the goods. We happen to be putting it on the job spot right now, but it doesn't have to be like that. We could temporarily override it to have a different destination that's next to our thing. Actually, I think I might just do that. For our furniture, we have job spot. I'm going to put another one that says get spawn spot tile. Okay, that's going to be like this, and I'm going to hard code this in for now to be one tile to the right of our job spot. Just to do, allow us to customize this. Obviously, it's going to be as simple. Oh, shit, I guess I could just do it for realsies. All right, let's do it. In our world class, that is where we define all of our furniture. And that is also where we're setting the job spot offset. So what I'm going to do is same thing as the job spot offset. Oops. Job spawn spot offset over here, which we're going to copy. Job spawn spot offset here. We'll also have to make sure it's clear later on. If the job causes some kind of object to be spawned, where will it appear? We'll do that. So we do this, and then I don't have to do a +1. I can just say job spot or job spawn spot offset. And because we're not actually setting it anywhere, it's going to be at 0, 0, which is going to be in the bottom left corner of the tile, and that's going to be fine. So I'm just doing it so we can see it. Having the material appear at our character's feet might be completely legit. Or, maybe it shows up on a tabletop, and then people can move adjacent to it to pick it up. There's all sorts of different ways, but for now, that's going to be fine, and this works. So now, when we create a furniture action over here, and we're going to place inventory. Right now, we're placing it in the job tile. I don't remember. Does the job have a reference to the furniture? It does. So instead, we're going to say place it at the spawn spot tile instead. Okay, we're going to come back to this in a sec. I'm just going to make sure these changes worked. Okay, no errors. Hit play. Load, well actually, new world, pathfinding test, that's going to be fine. Build the mining drone. And so the stuff should appear here, and it does. Okay, just makes it a little easier to see. I like it. And then we can tune it for individual pieces of furniture as much as we like so that we're happy. Okay, so now the reason I did that is so that I could check to see if our destination is full. Because what I can say now is furniture dot get spawn spot tile dot inventory. So if, whoops, if, I guess I can cache this. It's a pretty easy call, but there's a little bit of math. So tile spawn spot is equal to this. And we can say if the spawn spot's inventory dot stack size is greater than or equal to dot max stack size, we should stop this job because it's impossible to make any more items. Now, later on, we might change this so that items spread around. They don't just, spawn in one spot. But for now, this is going to be okay and allows us to give our characters a little bit of a break. So what we're going to do is say, so on our furniture dot job, I guess we can just clear all jobs. And then return. Otherwise, it's not full, so the job can stay there. So here, the job spot is full, so we cancel a job and then return. Otherwise, yes, we have a job, but the spot's not full, so we can still just return. Ultimately, this is just creating a job, right? If we get here, we need to create a new job. So either we are canceling a job or continuing an existing one or creating a new job. But there's going to be one more check over here. If we get here, then we have no current job. Check to see if our destination is full. So we have to do another check over here. I guess I can do this. That's fine. And then I'm going to do another different check over here. Well, it's the same thing, and I don't like duplicating the code. But it sort of kind of has to. Fine. Anyway, we are full. Don't make a job. So just return. Boom. All right. There we go. So now, if we hit play, and I just load up the default thing, and we build the mining drone. Whoa! We're getting errors. Line 78. I'm checking something that doesn't exist yet. Oh, because the spawn spot inventory is set to null. Right. It can be null. What do I want to do about that? Is there a chance we would like the inventory of a tile to never be null? So we could still just check to see if it's empty? And that's not really logical, because that would still imply some type of stack. So no, we have to check to see. Over here in furniture actions. Yeah, we have to confirm first. If the spawn spot inventory is not equal to null, and this, and then the same thing over here, is not equal to null, and, oops, and that. Okay, let's try that again. So, generic map, mining drone, and there we go. I should have increased the rate at this. At this point, I think it would take me longer to increase the rate than to just wait for the count to go up. Although it's awfully boring to do this. Oh my god. Yeah. I should just increase the rate. But in theory, once it hits 50, this job will stop itself. Or maybe the Unity editor will crash? That's highly unexpected. Are we generating a loop? How are we generating a loop over here? For each j in jobs, remove job. I mean, it should only have the one, shouldn't it? Although we are changing the array as we go here, which is not a very good idea. I wonder if that's what was going on there. Have we not called clear jobs before? We must have. But yeah, this is not good because we're changing. Our list of jobs is changing as we're trying to iterate through here. So what I should do is like, I should actually make a copy of this list and loop through the copy. That's probably much better. Actually, we could just make grab an array. Jobs array is equal to jobs.toArray, like that. We loop through the array, and then we change the list on the fly. I don't actually know if that's what caused the crash, but there's, yeah, this was not good. You don't change a list as you're iterating over a list. Leads to all sorts of horrible badness. So let's try that again. Interesting. This is not a bug with our new code, but I think we just exposed a bug. Pathfinding test. Oh, you know what? Before we do this, I'm going to increase the rate of the drone job here to spawn like 20 per go. So it should go 20, 40, and then cap at 50. Pathfinding test. I'll build the walls first. Not that it really matters, but just to show. So they can't do that because it's empty, because it doesn't have any material. Build the mining drone, start working it. 20, 40, 50. And we get a Stack Overflow. Really? I'm doing some... What am I recurring? Oh, hold on. Yeah, it's the job canceling. So line 212 here, we're calling remove job, which calls cancel job, which then calls the callback again. Right, that makes sense. Because remove job, When the job stops, we want to tell the furniture that it doesn't have a job anymore. The problem is, remove job is then canceling the job. Should it? How do we want to work this? I mean, there's a couple of different things I can do. I could just unregister, j.unregister job stopped callback, and do this. But the problem is, at this point, we have still called, we still started to call the job stopped callbacks, and in here we're going to be making changes to it. So we have to sort of differentiate removing a job from a list versus canceling it. So remove job should not... Wow. Remove job should not cancel a job. We're going to find out how many side effects we trigger over here. And the other thing, I think, is these furniture actions. I think this... I'm going to get rid of that for notification when job stops. Instead, I think the furniture will have a on job stopped job J callback, and we'll automatically register that. When we add a job, we're going to tell the job, hey, register job stopped callback on job stopped. And when a job gets stopped, we're going to want to make sure to call remove job J. And in remove job, we're going to want to unregister our callback at that point. So there we go. The furniture should keep track of itself. If we add a job to a piece of furniture, it should register a callback on the job to let us know when the job has stopped, because then we will remove the job at that point. And anytime we call remove job, we'll also clear that callback, because we might be removing a job from a piece of furniture that still exists for some reason, but we still have to make sure to cancel this callback, otherwise weird things start to happen. Okay, and then the more important thing, or another thing, is, not declaration. We want to see references. Who calls remove job? So we call it here on job stopped, which is fine. We also call it here in clear jobs. And we also call it here in furniture actions. When a stockpile gets worked, we remove the job from the furniture. But it's important to note that this doesn't cancel the job anymore. So instead, what we're going to say is cancel job, which will automatically take care of removing it from furniture. So before, we were saying remove it from the furniture, which would cancel the job. Now we're saying cancel the job, which will remove it from the furniture. So we've got that, but the other thing we have to check is what calls clear jobs, because again, the assumption before was that this would cancel the jobs, but it's not. And actually, this I don't like because it was clearing all jobs. It's much more reasonable if we say J, where's the job here? Oh, well, yeah, furniture dot. Oh, yeah, clear jobs, but this is different than stop jobs. So we don't have a reference to our actual jobs right now. Clear jobs just removes them from the furniture, but that's different from stop. So I think in our furniture here, we need a cancel jobs, which is, again, might end up accidentally editing the array. So we're going to do this, but instead of calling remove job, we're going to say j dot cancel job for each one. All right, I like it. So now here, instead of calling that, we say cancel jobs. And we've got another reference to it over here. So again, cancel jobs, not clear jobs. Cancel jobs. In fact, I don't even know if we need to call clear jobs anymore from outside. For the sake of for now, I'm going to make this protected. And actually, this can also be protected. I don't think anyone from outside our code needs to call that right now. And we're just going to do it this way. It might become public later on, but we're going to do it this way for now to prevent any sort of particularly weird issues where we're assuming the wrong thing. So let's try this. We are going to load up the pathfinding test. I'm going to build some walls over here. Then I'm going to build a mining drone here. We'll also have to retest the stockpile. You're going to do 20, 40, 50, do that. And then because the mining drone job should be at the bottom of the queue, we'll work on the wall at this point. We still don't have a prioritization or job filtering. So it'll work the wall until all the walls are done. And then it'll go back to working on the mining drone. And that's good. And then what I'm going to do is I'm going to let it run with an empty queue for a bit. Then I'm going to put down a stockpile area and see how that works. Okay, yeah, you'll work that. Now you're full, and you've got no job, and everything is fine. If I just tell you to build, say, a door, that's okay. And then you've got nothing going on. That's great. And if I build a stockpile over here, you will slowly start to shift the metal over there, and then you'll start to work on that. Okay, still a lot of work we're going to have to do to get the job system to work like particularly elegantly, but I think we've definitely moved forward. And again, this is, I mean, if we visually had a little hopper here for the mining drone stuff to drop, then that would make a lot of sense. Doesn't have to be where it has to drop, but we can now customize it on a furniture by furniture basis, which I like quite a bit. Okay, I think that is much, much better behavior. Well, that brings us to the end of today's video, which actually ran a little bit longer than I would normally like, but I think we have made some really nice progress here towards cleaning up the job system, Like, we enabled a new feature, but in doing that, we identified some areas where the job system could be cleaned up, optimized. We actually fixed an outstanding bug that we hadn't realized was in there yet, and that's great. So, thank you very much for watching another episode. I got another topic to do very soon. See you next time. Bye-bye. Thank you everyone who pledged on Patreon in April and who are supporting these videos from May through to early June. And to these mic check level supporters, we've got Wes Oldenboiving, Craig Mortel, Neil Balaki Milner, Speedy Savant, Valiant Cake Fiend, Aaron Toivson, Marius Field Vold, Jan Torrevel, Julian Auger Lafont, Stephen Stager, Michael McClintock, Kale the Quick, Drazion, Bite Rash, Adjective, Jason Yanti, and to absolutely everyone who watches and shares and favorites and subscribes to these videos. Appreciate you all. Thank you very so much, and I'll see you next time.